All right, don't write anything. I'm just explaining right now. Someone approaches us like a game show. If we win, you guys win, each person would get $100,000. Probably interested, want to know what they have to say, right? It all comes down to holding your breath, and it all comes down to a group effort.
My money's on this one.
It's you guys know how to swim, so. So, what it comes down to is, it matters how well you guys can do as average as a group. So the scenario of this hypothetical, not real, don't tell people I'm trying to tell you to do this, game show is you get to decide if you want to do it. If you want to do it, then you get locked in a room. When you get locked in a room, you hold your breath as long as you can. If the average of your class can hold their breath at least 30 seconds, the doors are unlocked and everybody wins $100,000. At the end, if you hold your breath, the average of your class is not 30 seconds, the door is still tight, air is sucked out, nobody leaves.
Oh.
Hypothetical, I'm not really telling you to do this. Okay, so we're using extreme example, obviously, to think about scenario here. You should not have a question of what I want you to put here. What should be here based off of what I just said? So I know for a fact that this is going to be mu. I know for a fact that this is going to be 30 seconds. But now I want you to think about it as far as actually understanding what's going on in a test. I have a couple different options here. Which one would I probably not want to use in this scenario? Not equal to wouldn't be very helpful, right? So I have two different options. I could be less than or I could be greater than. If we reject the null, that means there is significant evidence that beyond a doubt, it's probably going to happen. So should we, as a group, decide, well, let's test and see if we can't make it 100%. And if we don't say that we can't make it, then let's try it. Or should we instead say, let's make sure we can and make sure we're a reasonable doubt that we can before we try it?
Make sure we can.
Does that make sense? So that's the whole thought process behind this of, I don't want to say, I want enough evidence that we're going to die. And if we don't have enough evidence we're going to die, we might as well flip a coin and try it. Like, that doesn't sound like a good idea. It would make a whole lot more sense to say, let's figure out if we have enough evidence that we definitely can make it. If not, let's not risk trying. Does that make sense? All right, so just write down this part. You might want to write something about scenario above that if we make it, if the average is 30 seconds, then you make it. If not, you don't, or you win the money. Just something about the scenario.
I don't know if I trust other people with my life like that. Like
I would not do that.
If I could go
No, you can't go yet because we got to do it. All right, so we are going to so this is our trial, not like throwing you in there to try it. So you have to write down when. I think we've probably done the holding your breath thing before. When I say go, everybody goes at the same time. When you stop holding your breath, don't make any noises. Don't look at other people. Don't try to because people always distract and then it messes everything up. So don't do that. When you have to take a breath, make sure you pay attention to what time it is so that you write it down. Questions?
Wait, are we just going to 30 seconds?
No, so as long as you can. Because we want an average, so if you can hold it longer, you would help, kind of thing. All right, so everybody good with what we're doing? We're all doing it at the same time. Count down. All right. 3, 2, 1, go. And when you do, make sure you write down your time. If anyone is still going, just hold your hand up so I know that we're still going. So everybody's done? Okay. Now we're going to go ahead and have this conversation, even though it's kind of getting into tomorrow a little bit. So if this were state, we would have to talk about population, all that stuff, which we will. What's the other part that I put in state? So we would have needed to do this before we really started collecting data, but we can technically pick what our alpha is. What kind of alpha would I want for this scenario? A what? Why?
So we were like more confident that we're not going to die.
I want to make sure that it happens less than that % of the time. So if I do like 10%, like, let's see if we can do it. Be wrong within 10%.
And what's alpha?
We're getting into that conversation, but this is kind of like just the start of it. So like I'm kind of a day ahead with that. So like let's just pick 0.01 for today. I would probably want to go lower than that if your lives were on the line, but just as opposed to like 0.05, it makes sense that we wanted to go smaller. Go ahead and I know I've done it out of order, but go ahead and write down population and define your parameter as well. So what is our population? All students in Leonard's second period. And then our defined parameter, we'd say let mu be the mean amount of time that they can hold their breath. Go ahead and start plan and write method.
Go ahead and write what?
Method. Based off of what we've just discussed, we know this is how many samples? 1. What makes me decide if it's Z or T? Do we know a sigma? And it is a test for means. And just write, stated to assume that all conditions have been met. That is something that could possibly happen, especially in a homework problem. And if they ever say, assuming all conditions have been met, that means you get to skip random, normal, independent, and just write that. Now, obviously, are we random? No, we're not applying it to a bigger population, but I just don't want to deal with it right now as far as this problem. And it could happen on an AP exam too, where they would say that, because then they would have a lot of different parts to that problem, and this would be just a small part of it. All right, so we have to get our data for due. So one at a time, calling it out. So you guys will call it out one at a time to me, and then I'll call it out again so you can plug it in your calculators. So so don't do calculators right now. Just call it out when it gets to you. What? $43.
49. 60. 40. 52.
36. 47.
46. 45. 45.
46.
43.
45.
44. 45.
35.
Completely side note, tying in old stuff. What could possibly happen with these results? What? What else? Could be outliers, could be biased. Why could it be biased? Aware of the situation. So what kind of bias could it be? If people's lives were on the line,
I feel like it could be under coverage, because if your life's on the line.
well, not under coverage, it would be response bias, whether you lied high or low. So potentially we'd be setting that up for either somebody to be like, I don't want to be the one who looks like we're bad, so I'm just going to say I'm a little bit higher, or you want to be like, I'm nervous that I can hold my breath that long, so I'm going to lie and go under so that I have a little extra. Just kind of tying in other chapters. Okay, so I'm going to call them out, so be ready to type them in a list. $28, $35, $60, $29, $27, $41, $30, $38, $43, $49, $52, $60, $45, $40, $52, $40, $36, $57, $47, $60, $34, $46, $45, $34, $35, $46, $42, $50, $45, $44, $45, $43, $35. All right, so let's go ahead and do it like in the like we're going to do the whole test in the book.
How many did everyone get?
How many are there?
I got 30.
There should be 33.
I got 33.
Can you go through?
No. Hold somebody's calculator beside of yours and scan through really quick, and you'll find it. It's a whole lot easier than doing that way. It's just a whole lot easier. But also no. What's the next thing we're gonna have after X bar? What else?
Yeah.
Which we just talked about is should be 33. And so I'm gonna give myself a little bit more space up here just in case. So I might write on 2 lines. So my degrees of freedom is what?
32.
What else am I supposed to put up here? And what else? So general equation, x bar minus what?
It's 42.
General, like mu divided by,
The sigma or s over square.
which one is it? So if I type everything in the calculator, I'm going to start my problem like this, to where I have the layout, and now when I go to type in my calculator, I can immediately write everything down. So you now go to stat, test, and then which option? We can skip that one. So we can go straight to stat, test, t-test. And then I have 2 possible options to put there. I can either go through data or stats. Which one do we have? We have the data because it's already in our calculator, right? Like it's in a list. Is that right? Don't ask me. I can't remember which one's which. All right. So, what are you prompted with? So mu is going to be what? Oh, that's one thing I didn't write. Mu equals 30. And then put what list to put it in. And that's all that it asks for. Frequency, which should be 1, keep that. And so this is one to where I definitely think it's very reasonable to use the calculator. I wouldn't go through any steps other than this. It's going to give you your x bar, your s, your test statistic, and your p-value. So what do you get as your x bar when you do, like, hit enter and it's going to give you everything. So it gives our x bar to be what? 818. What does it give us as our standard deviation? Let's go to 4 decimal places.
110.
Alright, so now I'm just going to write those here. But it already did that math for me and told me that my test statistic value is going to be what?
8.0812. Right? We're just looking at the T.
Yeah. So this is something I talked about yesterday, the day before, but we hadn't gotten to it yet. I always choose to write this one as 3 decimals because that is kind of a reminder to myself that I am using these procedures and not the other ones.
That's why you did the x bar and 3 up there.
No, that's just what they told me. So if I draw this, where is 8 something going to be?
Way to the right.
Way to the right. Which means, what kind of p-value should we get with a number that's way over there?
Very, very low.
A very, very low. So this problem gives us a p-value of what?
It's 1.57. This is 80.
How do you know that?
8 zeros and then 2.
How do you do that?
And then what? 1 point. Tell me again.
1.57. E and 8.
This is when we do the
E to the.
Negative.
So if I wrote 1.57 down, I am taking this decimal and moving it over 9 times. So that gives me 1, and then the rest of them would be zeros.
I'm confused. Where'd you get the point of
That's what this means.
I got 1.577211.
E to the negative 9. This means times 10 to the negative 9.
And I have to write that.
So this is how you apply it right Because we're taking this decimal. You take this decimal right here and you move it to the left 9 times.
Wait, how did you find it? I did the TCDF thing. What do you do?
T-test.
You're still
You're still gonna get the same thing. But so I don't have to type this in my calculator. If you went through stat test, it's gonna give me that, and that. I don't have to do it.
So then, how do you transform it to 0, 0?
If whatever this is, there's one less than that 0 in front.
Why would that one be 2 though? Where did you get the 2?
I could write that stuff 1 5 7. There's just didn't have to write any numbers. Alright, so if we were writing this in context of the problem, and if you're working on calculator stuff, ignore me, keep going. What I'm just writing is conclusion. Oh, so I need to write what in between? So how would I start my conclude? So we reject what? The null hypothesis, which is y. Since the p-value is so let's answer this one. Like I said, there are different formats. You can do this one. Let's answer this one where it makes sense in context of the problem. So what was my first thing? We what? Do. So reject is do. Just to make this clear, these are my 3 decision places. We do have enough convincing evidence that, so let's say it in words. We do have enough convincing evidence that the average amount of time our class can hold their breath, what? So, all context specific things aside, as far as like, yeah, I probably still wouldn't do it. If it were something that were not so dire circumstances at the end, this would mean we would choose to take the risk because we have a lot of evidence that we would end up with a result that is higher than what was needed. Does that make sense? Yeah.
I know you said you get into it, but is the alpha number telling us the percent like risk that there is?
That's kind of how I think about it right now. Yes. It's like, when do we decide enough is enough? That's what alpha is. But yes, we'll get into it more tomorrow. Yes, but you're saying it the right way. All right, questions on this problem?